So we're looking at rational exponents. Now, rational exponents, let me give kind of a review. Let's say we have x to the 1/2. This is another way of writing square root of x. Now, x to the 1/3. Well, that's the cube root of x. And x to the 1/4. That's your 4th root of x. In other words, x to the 1/n is the nth root of x. So we want to be careful here. When we take, and let me do one more, say x to the 5th. When the denominator has an odd number, we're taking an odd root. So that means we can take, we can work with, say, x being negative. That's going to be all right. If we have an even denominator, we're taking an even root. That means our root is going to be plus or minus. Also, we could get an imaginary number if we take the even root of a negative number. So you want to be careful with even denominators, especially if you got a negative number in there. With odd denominators, we don't have to worry about it. The sign attached to the x will be the sign of the root. Anyway. Now what we'll do is we combine these. So let's say we have something like this. We have this. We could think of this as two things. 100 to the 1/2 times 3, or 100 cubed times 1/2. So what this means is 100 1/2 cubed and 100 cubed 1/2. So what this becomes is the square root of 100. We're going to cube it. Here, we're cubing 100 and taking the square root. So which one do you go with? Well, which one's going to be easiest? Is it easier to cube 100 and take the square root? Or is it easier to take the square root of 100 and cube it? So here we'll get 10 cubed, or 1,000. Here, we're going to get the square root of 1,000,000. That's equal to 1,000. But which way you choose to look at this, and the reason we get these two options is because multiplication is commutative. That means the order of multiplication doesn't matter. So depending on how you do this, you'd be taking a square root first and then cubing, or you could be cubing first and taking a square root. So whichever way you think is easiest is the way that you go. Now, what we're going to be doing is canceling rational exponents. So for example, let's say x to the 3/2 is equal to 1. Well, the way we can make this cancel is raise both sides to the 2/3. Now, in this case, we're talking an odd denominator, so we're taking a cube root and we're squaring it. I mean, it's 1. The cube root of 1 is just 1. And if you square 1, just get 1. This is just going to be 1. But these, as they multiply together, this just cancels. 3 times 2 is 6. 2 times 3 is 6. where x to the 1 is 1, or x equals 1. So that's going to be our approach with these rational exponents. So let's take a look at some others. Let's say we have this. Now again, we want to cancel by raising both sides to the 3 halves. So we're going to get this. So when we raise the exponent, when we give an exponent that's a reciprocal, or the flip of the exponent that's already there, the exponent and its flip, they're going to cancel. But what we do to this side, we have to do to the other. Now what's 4 to the 3 halves? Well, this is going to mean an even root or a square root, and this is going to be cubing. I'm going to do the square root first. So we'll get square root of 4 cubed, or 2 cubed, or 8. Finally, subtract 5 from both sides. We're going to get x is equal to 3. Now we do want to be careful here. This gives us the positive version of this. So one of the solutions is x is 3. But you might have noticed we took the square root of 4 and we went with the positive root. What if we go with the negative root? We went with the positive. So we back up. Now I consider the negative part. I'll start this over again. So x plus 5 is 4 to the 3 halves. We're taking an even root, so there's a negative root here as well. So 4 to the 3 halves. 4 to the 1 half times 3. Or 4 to the 1 half raised to the 3rd power. Or square root of 4 is going to be negative 2 cubed, or negative 8. So now we get x plus 5 is negative 8. Subtract 5 from both sides. Negative 13. So we get 2 answers here. And again, you do want to check them. So let's say we're going to check x is 3. So it was 3 plus 5 to the 2/3 equal to 4. Or put another way is 8 2/3 equal to 4. Or is the cube root of 8 squared equal to 4? So I see a cube root and square going on. Cube root of 8 is 2. And sure enough, 2 squared equals 4. It works. What about negative 13? Let's see. So it's negative 13 plus 5 to the 2/3 equal to 4. Or is negative 8 to the 2/3 equal to 4? Now we're taking a cube root and then squaring. Well, the cube root of negative 8 is negative 2. And sure enough, negative 2 squared does equal 4. So that means 3 plus an order negative 13 and 3. Those both work. All right. And that's pretty much it for negative exponents. And again, if any questions, let me know.